welcome everyone. Thanks for attending and thanks for having faith that we will learn something interesting. So I'm David Antunes. I'm a software developer. I've been programming Scala since 2013. I founded scalacademy.com, where I taught already many people in Scala. And I've been applying the ideas that I'll show here in this framework for a lot of years to develop web applications. So over the years, I worked with an Australian startup. We were developing enterprise software to manage Google Ads, and with lots of tables and forms and screens and reports and many of those things, and in other places. So I've been developing these ideas for a lot of years, and I've tried now to compile them into a proper framework. And I need to keep track of time, otherwise I don't want to get lost. So a special thanks just here to our first contributor in the framework. He's from China, and he has been helping to develop some important features in the framework already. Okay, so what do we want? So this is a web framework to create web applications, and I want it to be 100% in Scala. To work out of the box, so without complicated setups, just run the Scala server as simple as possible and not having to do too much complication and setups, etc. To be modular and reusable. So the idea with Fast Scala is to develop components that you will reuse and reuse and reuse, and they just work out of the box, okay? And have these components, and have one code base only for backend and front end. So not have like the separation backend, front end, and communication, etc. Just code everything in Scala all in one place. So for those of you who know, this will end up being kind of similar to this type of ideas, Vadin, for example. Okay, so you have an application, and now you can create complex UIs with your code, etc. So that's the goal. So there are similar concepts here to the Lift web framework. For those who know, it was one of the first web frameworks in Scala a number of years ago, not so popular today. And other types of continuation-based web frameworks, which I'll explain later what that means. So the foundation, it works on top of Jetty 12. It could work on top of many other things. Just I chose Jetty 12. It could be any other thing. So it could be re-implemented to work on top of other web servers below. But well, right now it's implemented on top of Jetty 12. So basically, it's a layer that sits on top of Jetty 12. Okay, so the foundational idea of Fast Scala, what's the main idea here? You have callbacks from the client to the server using anonymous IDs. And now you build on top of this. So let's demo here the callbacks. So, okay. So I'll show an example. Okay, so basically, we are sitting on top of Jetty 12. So we are responding to requests of a Jetty 12 server. Okay, so we get the requests, and I just made it as simple as possible here. Okay, so the most possible basic thing. So these are parts of the framework, for example, the OK.html. So these are just wrappers to just help you answer requests of Jetty requests. So this is nothing I created. So this is just out of the box Jetty. And like this. So here you have a page, basically it just responds with a page. So now let's get to the parts of the framework. Here we have an example where you have a button, a click me button, and so when we click this button, we have a code to create a callback to the server. So this FSC is FX Fast Scala context, and it allows us to create things in the library to interact with the library. So I say, I want a callback here, and when this callback is executed, the function I'm going to run is this. It prints on the server, clicked. And back to the client, I'm going to return void, so nothing runs back in the client. This is the most basic idea where everything else sits on top of this idea. So let's see what this code is doing. So it's doing here window.fastscala.callback. It's doing an anonymous callback with an anonymous function ID and the page ID, also anonymous, that was created by the server. So when you click this button, it does. Now it doesn't do anything because we don't have this code. So let's see here the next example, where in the page we install the basic, very small Fast Scala script just to handle these interactions with the server. Basically, it's not very complicated. It's just some lines of JavaScript, and now the callbacks work. And if you check in the server, now every time that you click in the client, you see here clicked in the server. So this is the foundational concept of the framework. Everything works on top of this, and now you build complicated interactions and UIs on top of this. So we can pass things to the server. So here we have an input, a text input, and now we say, okay, I want a callback, but get me the document element by ID, the value of this input, and pass it to the server. And so if we try this, the server receives the value and answers back, the server has received your value, the input, at this time in the server. And we get back to the client. So of course that we don't want to code like this, okay, with these basic things, but just to say that everything else sits on top of this concept, and now we just add more and more and more functionality on top of this. And I think that I'm going to be passing this button. Okay, so this FX context that we saw, it allows us to create these callbacks. And now, what can you have in the framework? So you can have the callbacks. Okay, I want the callback when this is invoked. Just run this function on the server, and then I can put this piece of JavaScript in a button, in on click, on change, anywhere you want. Again, as we saw, we can have a callback that has an argument as a string and is passed back to the server. And then, of course, we can build up on this. The framework already builds up on this. You can pass an argument as JSON, etc. So then you can pass anything you want. You also have another type of callbacks, file downloads. So this one now says, okay, give me a URL, a download path that's going to be anonymous, okay? It's going to be created on the fly. And the name of this file is myfile.txt. The content type that's going to be responded is text plain, and the contents of the file. So when the person clicks, it generates these contents. Here it's hard-coded, and like that. And the download URL would be the my site, etc., plus the download path. So it helps you create downloads on the fly. Uploads on the fly also. Same thing, same logic, same idea. So give me a file upload URL where when I receive the files are sent here, I get the files here, and now for each file I can do something, I can do whatever I need with the files, right? Send them to the database, S3, anything, and respond back to the server, okay, the upload was successful. Sorry, respond back to the client, not the server. Respond, okay, upload successful, etc. And now I put them in a form where the action is this upload URL. So usually we don't code like this. There are already structures that you don't need to be typing form, etc. Of course, this is just to exemplify what's below everything else.
David, a quick question. Who's responsible for writing the HTML, for example, as a form? Is the user responsible for writing this, or does the framework write it?
No, the framework then builds on top top of this and creates more and more complicated structures where you can just say, oh, I want a form, I want the file input, etc. So you don't need to be actually creating the form in HTML, basically. So it's below. It's below. We are going to see it next. And then also anonymous pages, okay? So I can say, give me the URL of an anonymous page, and then I send the user to an anonymous page. So the page is created on the fly when the user requests the page. Okay, and so you can see here the URL, so FastScala / anonymous, and with a random URL. And the page is created on the fly. Variables, we can have variables stored in the user session, okay? So we have created an object, for example, the current user extends FastScala session, variable optional, so it can be empty in the beginning, it's empty, and then you can get the value, you can set the value of the session that's stored, of the variable that's stored in the session. We can have WebSockets. So this is just a layer on top of Jetty12 WebSockets. Okay, I didn't implement WebSockets for sure from the beginning, of course. So you initialize the WebSockets. This is the code that you need to send to the client to initialize the WebSockets. You can of course initialize them when the page starts already, but if it's not initialized yet on page start, you can initialize it like this and then send things to the page. And then we increasingly create more and more complicated functionality on top of this, and we build on top of these concepts. Okay, so I'll just show you here part of the. I would like to give you later. Okay, so as you can see now we can create complex functionality, okay, all built on top of this. I'll try to give a demo with the time that I have left in the end, but so for now let's just, so there's fastscala.com, you can see this online where it has many demos, okay, and you can see that, okay, now I can create a simple table with a few lines of code. I can make that table sortable with another few lines of code. I can create a table where I can select the rows, etc. I can create a table where I can select the columns. I can create complicated forms where the values are updated from the server side and they go to the client side. I can do form validation with a few lines, etc. So then we are going to create complicated functionality on top of this. So we are not basically creating forms manually every time. So the idea is then to build up on top of these concepts. Okay, but I'll give a demo with the time that's left in the end, basically, with live coding. Okay, so the framework entities. We have sessions, typical session. We have a page. So a page has all these callbacks. Okay, so the session has pages, and then the page has the callbacks in memory. We have anonymous pages. We have the callback. We have the file download callback. We have the file upload callback. So this is a general overview. So you have the FastScala system. It has the sessions. Sessions have pages, also anonymous pages, and then the page has the callbacks there. The session also has variables. Okay, once the number of callbacks grow indefinitely, so if I'm keeping these functions in memory, won't I get out of memory very quickly? So, of course, we need to garbage collect the functions that we have in memory. They're being stored, okay, so that they don't grow indefinitely. But there is also a catch here, which is this. I worked for a number of time with the Lift web framework, and it has this same concept of having the memory, the functions in memory, but it's not very efficient. So here, when you create one of those FX contexts, okay, where you can interact with the library. It has a hierarchical structure, okay? This fx context has a hierarchical structure. And so, when you delete one, all the ones that are the children of it are also garbage collected. So, for example, if I need to re-render a part of my page, which is usually what happens if the page is open for a long time, usually I'm interacting with the page, and usually I'm re-rendering parts of the page. Okay. So, for example, here we have a table. Okay. This would be selectable rows. So this would be the usual table, okay? So where I can select the rows, etc. But here it has enabled debugging mode, where I can see here the parts that are re-renderable, okay? They show up in this blue, the parts that are re-renderable. And so you can see here the re-rendering happening, okay, in slower, okay? And so every time, here is the demo, so it has this number of callbacks. In this page there are 22 callbacks created, okay? If this is re-rendered, I'm not adding more callbacks because I'm discarding, I'm garbage collecting the old callbacks. It's always 22, okay? If you notice, if I change the pagination to 100, then the number of callbacks will increase to 108. So this is very efficient, and so we are not waiting for the garbage collector to run or anything, in the sense that we could be using weak references and just letting the garbage collection just delete all those things that we are not using if there is not enough memory. This is not the case, okay? So if I'm deleting a part of the page, I'm deleting those functions from memory, okay? So this makes it very efficient to have these functions in memory. Okay, so the models of the library. So here on the bottom we have JT12, we have the layer Fast Scala, so this takes care of the functions, the sessions, the pages, the garbage collection, all these things. And then we have these utilities that build on top of it. So this is the raw thing. You can use the raw thing, but then there's here FX templates. This has templates for the forms, for the tables, etc. And here it's templates bootstrap, which has support for the designing of these forms and tables, etc., using Bootstrap, the Bootstrap framework. Okay, so the styles, etc., everything in Bootstrap. You have the demo so you can use it at whatever level you want. Okay, so if you just want something very quickly happening, you can use to modify the demo. If you want to configure everything and create your own form library, well, I invite you to just use Scala, Fast Scala directly. Okay. Even the libraries, they are like there's form 2, form 3, right now it's form 7. Okay, so the libraries include different implementations because they evolve over time, and I plan to continue to just create more because sometimes there's different designs. Okay. Fast Scala here is agnostic regarding XML. Okay, the XML implementation, the HTML implementation. So these plugs and FS templates depends on this for Scala SML. So if you want Scala tags, etc., it should be fairly agnostic and easy to also have it. So use cases for this framework. If you want to have a fast development speed, so you need to have features quickly, buttons, tables, forms, and everything very quickly out of the box. If you have an application where there is high revenue per user, of course, we are keeping state in memory, right? So, I have millions of users and this is an online magazine and nobody pays anything. It's ad supported or something, and I don't have any money for it. Of course, this is not the good use case for that. Definitely, okay. And complex functionality. So, if you have the online UUID generator, I would not recommend you to use Fast Scala for this. Okay, so the functionality that you have is generating a UUID. Well, there's no point in using Fast Scala. Okay, so if you have forms and tables and complex UIs and modals and everything, that's when Fast Scala it's very, very good. Security, it's secure by default because, well, you need these callbacks to access the functionality in the server. So if the page is not generated, okay, you don't have the callback, you cannot access it. Okay. There's a keep alive. This is still on the topic of garbage collection, okay, and there is a keep alive every few seconds, okay, that's sent automatically by the page, and if we are still receiving the keep alive, then if we are still receiving the keep alive, the page is not garbage collected. It's not garbage collected. I mean, it is if there's not enough space, but first we go to the pages that are not alive. So if a very low amount of memory is available, we discard a percentage of the pages that haven't been in use for some time. Load balancing, if you have 10 servers, you need to guarantee that the same server is always serving the same client with the IP or any other scheme. So I believe this is fairly easy to configure in a proxy or any other software you're using for load balancing. But you need to have the same server serving the same client because the sessions are stored on the server. You can see the demo in fastscala.com. Well, we can go to questions, or I can give you, well, maybe, okay, questions. I can give you more of a demo, but I don't think there will be an workshop. So if you want to have your hands-on, you can come to the workshop afternoon, 3:30. I would like to give a demo in 20 minutes, but the talk is 30 minutes, so maybe let's go to questions. See.
So I have a few questions. The first one is the library seems to support Bootstrap by default. Mm-hmm. Do you have any plans, like in the future, to support, let's say, Tailwind CSS or maybe maybe CSS in JS framework or something like that?
So Tailwind, for example, yes. I mean, I have thought about it, you know, and it should not be that difficult, especially to adapt from Bootstrap to Tailwind. It's just a matter of CSS classes, etc. But you know that Bootstrap already has more of the components. So Bootstrap already gives you components. Tailwind, I saw it, and I don't think they give you the styling, but they don't have there's that many components. I think they sell you the components. If you want the components, I think they have something like premium or something where they sell you the components. So that's more of the reason why Bootstrap by default.
But it's really nice also like to be able to build some component by yourself. Okay, right.
Just stay in the frame of the camera.
Yeah.
And also, well, like it's really nice to be able to build some components by yourself. You know, to write components.
Sorry.
I mean the purpose of like Tailwind, like trying to like use Tailwind with the framework would be to like be able to write components by myself, for instance. So this is why I'm asking, like.
I think it's fairly easy. I think it's fairly easy to adapt to other libraries. I just chose Bootstrap because it has it out of the box, etc. And you know, so parts of the architecture here it's agnostic. You know, here it's more or less framework agnostic, and here it's oriented for Bootstrap, so the styling, the classes, etc. Well, I would love to do the live coding, but maybe I can. Well, there's not much time for live coding. I can give you here an idea of. Let's use the. I can give you here an idea of the. I can show here, for example, server-side push. So you can have this. You can have this the WebSockets sending to the page and updating the page. Other interesting things. For example, input groups. Okay, so using this Bootstrap. This Bootstrap logic of the input group, you can just say, oh, I want an input group with a label, first name field, and the last name field. And you get an input group with the first name field and the last name field. Okay. Modals, all kinds of things. Modals with forms, all types of, all types of radio inputs, all select inputs, and all this in a fairly easy to code. I invite you to come to the workshop so we can demo this. But okay, so for example, as you can see, okay, I want a multi-select field. The options is this sequence of strings, okay, with colors. I want to label it as colors. I want the size to be 8, and I need to provide an option, the option that I'm passing like to a string, right, to be rendered, where I'm taking here these colors. They have the name of the color and then the color itself, okay? And I want the help text to be multiple can be selected, and then you get to render it with the colors, the label, all the colors there, the help text, multiple can be selected, eight options of height, etc. Selectable columns. So you have a table and you say, oh, I want this to have selectable columns. You have a button that you can put in your widget, and you say, oh, I want this column selection drop-down button. I want it to be primary, so the blue one. Have a label columns, be small, and not close when I click inside it. Only close when I click outside. This is Bootstrap more functionality. This part of closing inside or not closing inside, etc. And so there is not this going back and forth between back-end and front-end. With the functionality that we're creating, you code everything in Scala. In server, you just say new window, new modal, new table, new form, etc. Render the form, close the modal, etc. And everything in Scala. So I invite you to the workshop for the demos and the coding, because if I would start now, we would run 20 minutes out of time probably. So, any other questions?
Final question. Does this framework support using external JavaScript library, for instance?
If it supports user?
No, using external JavaScript library.
Yeah, I mean, you can use any other JavaScript library. So this is just, but which JavaScript library, for example? Types of, because JavaScript libraries that manage the communication with the server, well, that you can do it, but then it's another logic, you know. So of course you can just, so this is just running on Jetty 12. So if you want to serve requests of other types, you know, oh, I want to serve post requests and other types of requests, not only the pages, okay. You can do it. You just add on top. Okay, you just put it on the side. Besides Fast Scala, you can also add more logic. Yeah. So it's not. I think it's not much complicated. So it keeps it fairly simple and doesn't add too much thing on top of Jetty. Very well. So if there are questions.
You talked about anonymous URL.
Mm-hmm.
Do you also handle the routing of the web application inside FastScala, or you have to do it outside?
Where the page is processed, where it is generated.
Yes, and how do you handle the routing of the web pages?
Yes, so Fast Scala will be a handler of Jetty. So the request will come, and one of the handlers is Fast Scala, and then it's it starts with FS, then it's anonymous, and then it has the ID. Okay, I have a function that matches this anonymous page ID. Oh, and please generate the page for me to give back to the user, basically. Yeah. So that's the logic.
So basically, internally, you keep like a map
Mm-hmm.
of user ID and an object which is
Exactly.
an apply function.
Exactly.
And so when the communication, when you call first you send the JavaScript to the page which contains this ID and manage how to replace the HTML directly?
I mean, you send the JavaScript, it has the ID, then you click a button or anything, and then it goes back to the server. And if it's a callback, the server runs the function and returns JavaScript. If it's an anonymous page, the server renders the page and returns the page rendered. If it's a file upload, so it depends, right? So you have all these anonymous IDs, and then it just depends on what type of thing that you're doing on the server. Yes.
And so you were speaking about the keep alive because it's very important to clean this map. Someone
Yes.
Leave.
Yes. So you have the keep alive. So if there's no space, you just a percentage is going to go down, and then you can configure what happens when the function is not there anymore. You see, so you may redirect the user, you may reload the page. The reloading the page is the usual situation. You see, so you have the keep alive, and you keep track. So if there's a callback, it also updates the keep alive. So the user is in the page and clicks a button, okay? So that page will have priority to stay in memory over other pages that are also open, but there's no activity. So, yeah.
Okay, so there is an active, you have to implement something to keep the memory actively. It's not based only on reference and garbage collector. No, things keep there. But if the framework sees, okay, there's very little memory, it runs the garbage collection. And if there's still very little memory, then okay, let's delete 5% or 10% of all the callbacks. And then if there's still very little memory, you continue. And when there's already like 5% of the memory available or anything, it's configurable in the settings, right? And
then
in the GVM, there is no like callback. Oh, sorry.
Mm-hmm. Yeah, sorry, we have to stop.
We can't continue.
You don't have a callback to know that you will have a garbage collection. Something like, warning from the garbage collector that we may need to clean memory.
No, it would run periodically. It runs periodically. No, and checks periodically.
Thank you.
Thank you, everyone.